Okay, so continuing in section 6.3, we've kind of hit a lot of information that and move into what they really tell us. So first of all, a percent is a ratio that is always out of 100. So if our percent happens to be the letter A, so a percent is always thought of as A over 100. All right, so it's always out of 100. So what that allows us to do is kind of see this very specific way of looking at these that connects to a lot of ideas we've already talked about, especially in chapter 5. Okay, so for instance, if I wanted to use a grid to represent the percent, oh, let's do 9%. And I would need to do 100 grid. And I would shade 9 of them. So almost an entire column. Okay. If I wanted to, I'd still need to use 100 grid. Though I know I could probably try to get away with a 10 little fraction bars. It's still got to be out of 100 because that's what makes it a percent. So 90 is going to be all columns except the last one. All right. We've seen this before. It just has to be out of 100 in order for it to work. Okay, another thing that we have seen before is that we could write percentages because we can see them as ratios. We can write every percent as a fraction. Let's do 42% as a fraction and decimal. So as a fraction, our definition always has it out of 100, so we could put it as 42 over 100. Now we can reduce that number. 42 over 100 reduces to, let's see, I can divide by 2. I'm not even sure. I think only 2, which will give me 21 out of 50. Okay, there we go. So yes, there's the fraction, but it also lets me write it that it's 42 in the hundredths place, which would just be 0.42. Now, a lot of people use the trick with percentages that they just move the decimal 2 places to the left, and you always move it 2 places to the left because it's out of 100 and it works. That's a way of converting percentages to decimals. But that's all kind of just a little trick ways for us to understand how they work. I think that's kind of the big ideas that we've talked about. Let's go the other way though. Let's say we want to start with like a fraction. Like let's do the fraction. Change 1/5 into a percent. Now, we're supposed to remember certain fractions, and this is one of the fractions we're supposed to remember as a decimal. And hopefully you do, but if you don't, 1/5 is 0.2. So that would be our decimal. But that's not what we want. We want it as a percent. So to change it to a percent, sorry, I don't know why I boxed it. To change it to a percent, we're going to want to move the decimal the other direction. We're going to want to move it 2 places to the right, which would give us. Okay, so suppose we don't know the fraction. Let's say, let's change 11/4 into a percent. Okay, so we would want to actually divide, just do the division of the fraction. So 4 divided into 11. So 4 goes into 11 twice, which is 8, and a remainder of 3. And I'm going to go ahead and add a decimal and a 0 and keep going. So 4 into 30 would go 7 times, which is 28. And that's going to give me 2, 0, 0. Okay, 4 into 20, that goes 5 times. Yay. And I'm done. So 2.75, that's the decimal. But now I'm going to need to move the decimal 2 places over. So the percent is 275%. All right, now where percents are pretty useful to us is some applications that we can use with percentages. So typically there's a couple ways to kind of do this. Some methods use proportions, and our book uses the equation method. So the way that our book thinks of it is we can take a percent of a whole, which will result or equals some part, which as an equation means that we would have a percent times some giant amount that we're working out of, and we would get some part of that amount. All right. So let's say I'm trying to think of a good example. How about 20% of football players can get or have had a knee injury. Had a knee injury. Wow, that's not how you spell that. Injury. If there are 1,180 players, how many have had a knee injury? Okay, so if I use my kind of general equation setup here, I would be able to plug in my information directly into this equation. So the percent, which is 20%, and then times the whole. So if I'm doing 20% of football players and I happen to know there are 1,180 players, that is the whole number. So that, here, I think we should use the X, not the dot. Sorry, our book typically does the X. So it should be 20% times 1,180. And what that equals, I don't know. So I'm going to call it X. Now, I'm never going to leave it as a percent. In fact, me writing writing it this way was like really difficult because I never write percent either fraction or decimal. I typically just do decimal because we're going to use our calculator and it's just easy to work with. So I'm going to go ahead and write 0.20 times 1180. So I moved the decimal twice. Okay, so 0.20 times 1180, grabbing my calculator, I'm getting 236. So 236 players have experienced the knee injury. So that's how we could kind of use this basic equation to help us solve some of these little problems. It is, like I said, possible to use a proportion. That's possible too. But the way that one's set up instead, the proportion version, and actually I just see the book does talk about that. So just kidding, they do both. The proportion version of this equation uses percent over 100 equals part over whole. So let's do an example where maybe we use this setup instead. Both setups work, by the way, for these equations, but this would be how we could kind of do this. All right, so at one point, Nebraska had 112 schoolhouses. Wow, that's one word, sorry, schoolhouses. This represented 23% of all schoolhouses in the United States. Here, I'll put the US. In the US. So how many schoolhouses were there in the United States? At that time. Okay, so if we're going to use this kind of proportion setup, I would take the percent, which I do happen to know is 23, and I'm going to drop the percent symbol because I'm literally writing as a fraction, 23 out of 100. And then I need to determine whether the 112 is my part or whole. And the easiest way is to look at the percent statement. So it said 23% of all schoolhouses in the United States. And the question is, does 112 represent all schoolhouses? And the answer is no. That only represents schoolhouses in Nebraska. So that means that's the part. And the whole, we don't know. That's how many schoolhouses are in the US. Okay, so then to solve this, we would do a cross multiplication. So I'm going to cross multiply. So 23 times x is just 23x. 100 times 112 is 11,200. And then if I divide by 23, $11,200 divided by 23 gives me 486.956. 486.95. Actually, here we'll just say 96, which basically is 487 schoolhouses. And there you go. That's how we could use the proportion version to set up the equation instead. So both work, and they also have this whole thing about trying to confusing. So if it mentions that in the homework, you do not have to do a grid to represent this.